Hey guys, welcome to the pre-algebra video for 6.5. We're talking about similarity and measurement in this one. So similarity, what is similarity? Let's review. If we see that symbol, what does that mean? It means two things are similar, right? So some similar figures, you could have, two right triangles that are also congruent, right? So if this is triangle A, B, C, and D, E, F, right? We could say, oh, you know what? A, B, C is similar to D, E, F. Why? Because it has the same size or the same shape, but it also looks like it has the same size. So these two triangles, remember, are similar because they have the same shape, but they're also congruent because they not only have the same shape, but it looks like they have the same size. And if we wanted to make sure of that, we could say that and that, that and that, and 3 marks there and 3 marks there. And we would also say the angles are all the same as well. Okay, so remember that's similarity. Similar means same shape and maybe the same size, not necessarily. But if they're similar figures, remember the things that have to be the same are not necessarily the sides, but the angles in similar figures must always be the same. So angle C must be the same as angle F with these two figures for it to actually be similar. All right, so let's review ratio and similarity by just talking about these two figures, okay? So remember from the last video, we said that if two figures are similar, which we'll say these are, all right, so just like that, right, triangle ABC is similar to DEF. Remember, similar means not necessarily the same size, right? So this length here is 4 inches, this is 6 inches. So we know they're not the same size, but they are the same shape if they're similar, right? So if they're similar, and they have the same shape, then there's a proportion there, okay? There's a ratio of the length of sides, and we can figure that out. So remember, to figure out what that ratio of the lengths of the sides is, you can take one side and divide it by the corresponding side on the other figure, right? So this side here in this triangle ABC, right? We're going to look at the side AB. Okay, side AB is 4, all right? So we'll do A, B. And we're going to divide that by its corresponding side from here. Well, AB is the first two letters in this triangle. So what are the first two in this triangle here? DE. Side DE is 6. So we're going to divide AB, which we said is 4, divided by DE, which is 6. Right? So the ratio is, it's kind of 4/6, but we need to simplify. Divide by 2, divide by 2, you get 2 over 3. So what is the ratio of the lengths of these similar figures, of the sides of these similar figures? It's 2/3, okay? Which helps us a little bit because, and this is kind of what's new today, I'm going to just draw these figures again real quick. All right, so sorry about that. It helps us because what we're learning today is finding unknown sides of similar figures using ratio. Okay, so we said the ratio between these two figures was 4/6, which we simplified to become 2/3, right? So let's say we also know that this side here is, we'll do 8 inches, okay, AC. And remember, these are similar figures. So let's say we know that AC is 8, and we want to know what is side, wrong side. What is side DF? Okay, how do we figure that out? Well, here's the cool thing, all right? The ratio says it's 2/3. So it means if something over here is 2, then over here it's going to be 3. If something over here, well, you can multiply it. If it's 4, then the thing over here is going to be 6. So something over here is 8. What does that mean about this? Well, check this out. We're actually going to set up a proportion, okay? And we can do this because they're similar figures, okay? It's only because they're similar figures. And it's going to be kind of similar with the ratio, okay? So we said up here the ratio, AB over DE was 4/6. So what we're going to do is set up that same thing, okay? So I'm going to pick one side from here and then its corresponding side from here and make a fraction, right? So we're going to do AB over DE, okay? But what we're going to do is set that equal to, so here's the first fraction on the left side. are two things that we know, okay? And what do I mean by that? Well, we know what AB is, right? It's 4 over, we know what DE is, it's 6, okay? What we're going to do is we're going to set that equal to another measure from the black triangle that we know, okay, and that's AC. And we're going to set that over AC's corresponding side from over here. Well, A and C are the first and third, so the first and third here are D and F. D and F. Well, guess what? I don't know D and F, and what do I do if I don't know something? I write a variable. Okay, so now I'm going to fill in down here. We said AB over DE was the same as saying 4 over 6. And let's go here. What is AC? Well, AC is 8 over DF. Well, and yeah, I should have written DF there. I'm sorry. DF. We don't know what DF is, so I'm going to insert the variable x. So in order to find DF, look what I can do now. I can solve a proportion. All right, so let's solve this proportion. How do we solve proportions? Well, we can do what? Cross multiply, right? And first of all, can I cross cancel here? Is it okay for me to cross cancel when I'm solving a proportion? No, it's not. Okay, you can only cross cancel if you have your multiplying fractions, such as 3/4 times 2/9, right? I could cross cancel there and do a 1 and a 2 and cross cancel there and make that a 1 and a 3. But here I cannot cross cancel. So the only thing I can do is I could simplify this fraction of 4/6 to make it 2/3. And now I could cross multiply. 2 times x is going to equal 3 times 8, which is 24. Now if I just divide by 2 on both sides, I get that 2 out of there, which gets x by itself. Now I have x equal to 12, okay? And so what does that mean? Well, it means that missing side we were solving for, which was DF, is what? It's 12 units, right? Or 12 inches, I guess, in this case, okay? So that's how we use proportions to find the sides of similar figures. All right, so I want you to take a minute and I want you to pause the video and I want you to try this one, okay? What you're going to do here is solve for x. So I've given you two similar figures and I want you to set up a proportion like we just did in the last problem that helps you figure out what x is if you know these 3 other side lengths. So pause the video, play it when you're done, and let's see how you do. All right, so what I would do, again, is say, all right, I'm going to set up a proportion, right? So some fraction equals another fraction. I want my first fraction to contain, all right, and it doesn't have to, but I think it's just good for consistency's sake to do this every time. One length over another length, okay, and those are lengths that you know. So no variables on this side, if you can help it. It doesn't matter if you do, but I think it's just good to be consistent. So I know side BC, okay, it's 12, right? So I'm going to set it up with the letters first. I'm going to do BC over his corresponding side here. Well, what is BC's corresponding side? Well, BC is the second and third letters. So the second and third letters here are FG. And look, there's FG, okay? And I'm going to set that equal to another side that I know from the orange figure, okay? And that would be AD, right? AD. And who is AD? AD, not AB. AD. And who is AD's corresponding side over here? Well, AD, first and fourth. So first and fourth there is EH. And yeah, I mean, it definitely looks like that obviously has to be the corresponding side, but it's good to check. Okay, so AD, first and fourth here. EH, here is side EH. Okay. And because these are similar figures, it means this proportion is true. All right, so BC over FG. Well, let's see. BC we know is 12 over 12 over FG. Well, FG here is 30. And that's going to equal, because these are similar figures, so we're forming a proportion. Let's see, AD, which is 16, over EH. Well, EH is unknown. We don't know that, so that's what we're solving for. Okay, so how can we do this? Well, let's think. I'm going to cross multiply, actually, but I'm going to simplify one of the fractions first. 12/30ths, I could simplify that If I divide both of those by, if I do 3, well, no, that's not going to be quite enough. Let's do 6. That would be 2. 30 divided by 6 is 5. All right, so now we can cross multiply. 2 times x is going to equal 5 times 16, right? So 5 times 16, not the friendliest of multiplying, but that's not bad, is 80. I'm just going to set it up like this first. Okay, so 2 times x, we can just make 2x, right? And let's see, 5 times 16 is going to be 80. And so in order to get x by itself, I have a x being multiplied by 2, so that's just divide by 2, but I have to do that on the other side as well. And then that gets me x to equal 40. Okay, x equals 40. So let's see if that works out. If x is 40, okay, which means this would here have to be 40, we're talking about meters. That means if I plug this 40 into my proportion, it should give me one fraction equal to another fraction, right? So let's see, we started out with 12/30ths, and that equaled 16 over, now instead of x, we're putting in the 40. So we're going to check to see if this is true, right? So let's simplify both these fractions. We said 12/30ths could simplify to be 2/5. And let's see, could we simplify this to also equal 2/5? And if we can, then we actually know we've done our, our math correctly. So let's see, if I divide both of these by 8, well, 16 divided by 8 would be 2, and 40 divided by 8 as well. So again, I'm dividing both of these by 8 to simplify. Well, 40 divided by 8 is 5. And you know what? When you simplify both these fractions down, these ratios, guess what? You get 2/5. So that means we did our work correctly. And that it means that this side here is no longer unknown. We solved it, and it's 40 meters. So here's one of the other cool things that I like about proportionality and similar figures. So what we're going to do is actually determine the height of this cactus, okay? So you're out in the desert, right? And here you are, and you're looking at this cactus, and it's humongous, and you want to know how tall it is, right? But you only have yourself, right? So let's say you know you're 6 feet tall, okay? And you are like, well, I got to figure out the height of this cactus. I can't climb this thing. I don't have a ruler. How can I do this? Well, fortunately for you, there's this thing called the sun. I don't know if you've heard of it or not. It, provides light. It's pretty cool. Big, hot. Anyway, so it's casting a shadow, right? It's casting a shadow. So the cactus has a shadow, and you also have a shadow. Okay, so you're 6 feet tall. So let's say you look at your shadow and you lay down next to your shadow, and you're like, that shadow is approximately 1/3 of my height. Okay, which would make your shadow then, 2 feet. Okay, and then you go next to the cactus and you start laying down at the base of the cactus and figure, okay, let's see. And this actually is not quite drawn to scale, so let me fix this a little bit real quickly. Pardon. Okay, how about that? That might work a little bit better. Anyway, so you lay down the cactus and you see that its shadow is not quite to where it's not quite as long as your height. So you approximate, it's about 5 feet. Okay, so it's not quite as tall as you are. So anyway, now you actually have enough information to figure out how tall this cactus is. And here's why. When the sun is casting a shadow, what's actually formed here is a right triangle. Okay, so I'm going to draw a dashed triangle here. So it goes down the center of the cactus. Oh, that's not going to work. And it goes to the end of the cactus's shadow. And all of a sudden here you have what's formed a right triangle. But also you have a right triangle too. Okay, it goes through to the top of your head, through the center of your person, and then over to your shadow as well. Okay, and because you have a shadow that is being cast by the same sun that's casting the shadow on the cactus, these two right triangles are actually similar. Okay, they are similar right triangles. Okay, and again, my scale's not great, but they are similar right triangles, I promise you. So here's the cool thing. Now you have a proportion. And what are we trying to figure out? Remember, we're trying to figure out the height of the cactus, right? We're trying to figure out how tall that cactus is. And now you have enough information. So we're going to set up a proportion. So some fraction equaling another fraction, okay? So we're going to set up a proportion on this side with two things we know. Okay, so I know that your shadow's length is 2 feet, and the cactus shadow length is 5. Okay, so I'm doing shadow over shadow, your shadow over cactus shadow. Now, in order to figure out what goes here, I need to go back to you and figure out what's the other measurement we know. Well, we said that you're 6 feet tall, so I'm going to put a 6 here. And then how tall is the cactus? Well, we don't know, so what do? Put a variable. So what we can do now is solve by cross multiplication, or we could use mental math, but I'm going to cross multiply just to always be sure. So 2 times x is 2x, and that's going to equal 5 times 6, which is 30. Last step to get x by itself, divide by 2, and look what you have. X equals 30 divided by 2 is 15 feet. All right, so if we go back up here, what does that mean? It means the cactus is 15 feet tall. And you know how you found that? All you knew was your height. Okay, you found the length of the shadows using your height laying down on the ground, and all of a sudden now you know how tall a cactus is, and you look super smart to all your friends who are out in the desert with you baking in the sun. All right, guys, that's all I have for you on this video. I look forward to seeing you in class, talking more about shadows and cool stuff and cacti and similar figures and all this awesome proportional stuff. See ya.